What we want to talk about is some research that we've been doing in the mobile landscape. We've been analyzing mobile apps so that we can understand them, see what vulnerabilities they may have, what privacy issues they may have. The company, you may not be familiar with Zscaler. We're a SaaS-based solution for web and email security. We're all over the world. We're based here in India as well. We have offices in Bangalore and Chandigarh. I run the research arm of the company, as was mentioned. I've had the good pleasure of speaking at... Oh, okay. Hold on. One small technical difficulty. Oh, I think it fell down. I think that was the problem. How's that? Can you hear me a little better? Perfect. So I run the research arm of the company that we call Threat Labs. I've had the good fortune of speaking at a lot of security conferences around the world, and I'm certainly proud to now be able to add Nullcon to that list. Pradeep, he's a senior security researcher with our company, and he is the individual that led the effort to build the tool that we're going to release here today called ZAP, the Zscaler Application Profiler. You guys actually get to be the first people in the world to see this outside of our company. So what we want to do is talk a little bit of background just about why we should be caring about mobile and how mobile is really changing the landscape, because it really is going to change how we approach security. We want to spend the bulk of the time on ZAP, the Zscaler Application Profiler. We're going to tell you why we built it, how we built it, and then most importantly, release it to you, because it's a tool for you guys to use. And learn more about the mobile apps that are on your phone. And then we'll talk about the findings that we've discovered to date and wrap it up with where we think things are going from here. So a little bit of background. When it comes to the web, there was, of course, an explosion of growth. This is a chart from Netcraft. If you look at, it took till about 1997 before we had 1 million unique host names on the web. 4 years later, 10 million. And today we're approaching nearly 100 billion unique host names on the web. So tremendous explosion in growth. Well, that had security implications. Like if you go back more than 10 years, which is when I got into the industry, that's why I have gray hair now, it was very easy to find vulnerabilities in web applications. There was a lot of low-hanging fruit, if you will. And the reason for that is that everybody was trying to quickly develop web apps. There wasn't a lot of good knowledge out there in terms of security and best practices for development. So there were just tons of vulnerabilities. And we're still not perfect today, but things are slowly getting better. Now, if you consider what's happening in the mobile space, history is repeating itself, only faster this time. Look at that chart. It was only 4 years ago that we had the app stores emerge, and at that time there were just a few hundred apps in these mobile app stores. And today, we're over 750,000 apps in each of the app stores. Actually, Google announced 625,000. So there aren't a lot of good development practices. There aren't good security tools. There isn't knowledge for security researchers in the mobile space. So we're seeing a lot of low-hanging fruit. We're also seeing a lot of malicious applications start to sneak in. It is today largely a problem in the Android stores as opposed to the Apple iOS stores, more so even in the unofficial app stores. But this is becoming a big problem, that the attackers are realizing that here's a great medium. I don't need to go trick you. I don't need to social engineer you into finding my app, because there's one place where all the apps are stored. And if I can sneak an application in there, I can get you to download it and get my malware out that way. And they'll do things like clone popular applications. So you may think you're downloading, in the case of the story on the right, Grand Theft Auto, but you're actually downloading a Trojanized version of that. Now, when it comes to mobile application security, Google and Apple have very differing philosophies. And at least in the case of Apple, their philosophy isn't really driven by security. It's driven largely by the user experience. So it's often, their approach is often referred to as a walled garden. They build a wall around this beautiful garden, and they control everything in that garden. And Apple will reject applications for a lot of different reasons. And they don't really feel the need to explain themselves. Sometimes they're doing it because something violates the SDK. Like there was the Path application, which is a popular social networking application. It was grabbing your contacts without knowledge, which is in violation of the SDK. even though the SDK didn't explicitly prohibit it. So when Apple found out, they reprimanded Path for doing that. They may censor things just because they don't feel that they're appropriate. There was an app called Drones Plus, which would highlight the location of drone strikes in Afghanistan, and Apple said, we don't feel that's appropriate, we're not going to allow that. Or Clueful, pardon me, Clueful was actually a very valuable app, a security app that Bitdefender had that would monitor the processes on your phone and then tell you if there were any that had privacy or security risks. Apple didn't like that, not because there was anything wrong with the app, but because it made Apple look bad. They also say, this is their term, any content that is over the line, typically things like pornography or inappropriate content. They do not permit that. Or what they call weak applications. Actually, in the guidelines that they provide, they use that term, amateur hour. They're basically saying, hey, we expect your apps to be brilliant. And if they're not brilliant, and we don't think they are, we're not going to allow them in. Contrast that with Google. Google lets pretty much everything in. They want to, by design, be very, very open. And they're really only reject an application if there's some sort of security or privacy risk associated with it, or if it is in violation of copyright. But they've tried to take a very open approach. And when it comes to app permissions, Apple also takes a different approach. In Google, up front, they tell you, hey, these are all, when you install that app, it says these are all the things that this app needs to do. Do you want to accept it? Whereas Apple's approach is more one of only as that functionality is required. Like if an app that you've been running for a few days suddenly wants to know your location, then you get a pop-up and it says, hey, I want this functionality. So again, different approaches. Now when it comes to the App Store approval process, different again. You'll notice a lot of question marks on the Apple side. And that's because Apple is a black box. They don't tell you how their approval process works. We certainly know that there are manual teams that review things, not necessarily for security purposes, more for that usability and making sure it's a strong application. But we also have evidence that there is some automation in the process. And where we saw evidence of this came about a year ago when a number of developers reported having their apps rejected because they had simply used the name of a private API. And they hadn't actually used it, they just happened to have the same name for one of their functions. And obviously this automated system had seen that and thought that they were using a private API, which is a no-no, and Apple rejected it. Google, on the other hand, totally different approach. They used to be very open. They implemented recently something called Bouncer, which is an automated system that scans all applications in a virtualized environment before they get into the store, which is a very smart approach because it's pretty hard to manually review 500,000 applications. But we've found that Bouncer isn't perfect. There was actually a really good talk last year at Black Hat where two researchers purposely submitted apps to the App Store that would then give them feedback, and they would try to figure out what Bouncer was doing. And they figured out things that, like, it was a QEMU process emulator that was being used. It was running on Linux. But they found that you could fingerprint it. You could tell when your app was running in Bouncer because it would use the same canary data, like if it would use the same phone number. It would come from the same IP address block. So that opens Bouncer up to attack, that you could create a malicious application that if it knows it's being run in Bouncer, the malicious behaviors don't exist. Then when it's being run on a normal person's phone, then it can act maliciously. So now I want to get to the interesting part of the discussion to talk about ZAP, the Zscaler Application Profiler. So what we wanted to do, so we as a company, we have built this global network of web proxies, and so we're filtering traffic and monitoring it. So what we wanted is to be able to know that traffic coming through one of our nodes was from a particular application. So in order to do that, we have to fingerprint it. Now it's pretty hard to be manually fingerprinting all these millions of apps. So we wanted to build something that was very scalable, and we've done that. That's ZAP. But then we want to release it to the general public so that you too can be analyzing applications. You have an app on your phone, you say, oh, I want to know what this actually does. What traffic does it send? ZAP is hopefully a very simple tool that will allow you to do that. That was our goal, to make this purely web-based, make it a very simple and intuitive interface. And it really has two primary pieces of functionality. Search, which Pradeep will show you. You can search the historical database to see how we've ranked an application. We look at it in 4 different categories, give it an overall rating. And then scan functionality. You can actually scan your own app. And Pradeep will walk you through that. You basically pick the app that you want to scan, tell Zap that you want to do it. Zap will give you some proxy settings to put on your phone. So now that app traffic is going through Zap. Zap will capture the traffic, run a bunch of engines to analyze it, and look for privacy and security issues with that. Come back and give you a report. So with that, let me hand it over to Pradeep to walk you through Zap.
Yeah, thanks, Michael. So as Michael told you that the goal was to build a web-based API, a web-based tool which will be handy for all the users to analyze the mobile application with that tool. So I'll be talking about the Zap process, how it works, and what kind of report we are will be showing to you guys when you will be analyzing an application. So first of all, you have to identify an application URL which you want to scan into Zap, then get that URL from iTunes or Google Play Store. Currently, Zap only supports these two stores. And the purpose behind getting an application URL is that we want to have a clean data for that application, so we can say that this application was falling into this particular iTunes category. So the first step would be like identifying application URL. Second, if you want that the traffic coming from your device wants to be captured, the SSL traffic which is originating from there, it wants to be captured, then you can install a certificate, SSL certificate. So basically on the back end, we are using MITM proxy, which is a open source Python-based proxy. So we are using the SSL certificate of it. The third would be that, as Michael talked, we are looking for the security and privacy issues for the canary data. So the canary data is like your personal identifiable information. So if you see, like most of the application require registration and all. So you, for that, they require your first name, mobile numbers, last name, email ID, and all this stuff. So we are calling that as a PII information. So this is totally optional, and when you enter, it should be a fake information, but unique in nature, so we can analyze it and get the result out of it. So when it entered, the possibility is that you'll get the best result from Zap. So after that, when you start the Zap, it will give you the proxy settings, the server name and the port for it. Then you have to enter that into your Android device. For this operation, we are giving 2 minutes of timeout. So then you have to start the proxy and capture the data and analyze it through the installation process. So how would you identify an application URL? Like all the URL, just you can do a simple Google search like iTunes, Angry Birds, and get that application. And that application should be installed on your phone, so you can capture the traffic for that application. So we talked about the PII information. So there is an interface to enter the fake canary data or the PII information into Zap. So that will be used while analysis. So this is how you can set your proxy settings on an iPhone device. If you are connected on Wi-Fi, just go to the manual settings, enter HTTP proxy in there, and just try to use it. So we'll have a demo of Zap. So I'll try to show you some of the things which are already there. So the first functionality which is there is a lookup on an application name. So if you have an application name, you can do a directly lookup. So we have already analyzed some applications which are there, which are already there in the database. So you can do a manual lookup by typing an application name, let's say Temple Run. And if you want to get the result for an iOS device, so you can type as in Temple Run space iOS. So if you could see that we have rated this application on 38 on the scale of 100. So we have divided the analysis into the 4 buckets. The first bucket is the authentication. So here the idea is that if your authentication credentials are sent on a clear text, or are using weak encoding format, which is going on onto the network, like base64 or MD5 hashed or something. So these are kind of a weak encoding techniques which are there. So if we found such things, then the authentication bucket will go up. So there will be a risk score associated with all these checks. So likewise for the second bucket, like device metadata leakage. So here I mean the device unique identifier, if it is going onto the network, let's say to third party, all this stuff like OS version and all. So PII is that we just talked about. If you enter that PII information, if that is being leaked on a non-SSL channel or in a clear text, so the risk score for that bucket also goes up. So the last is like exposed content. The exposed content is like if your application is exposed to the third-party APIs, third-party sites, and advertising sites. So this is how when you will do a lookup in ZAP, this is how the report will appear. So about the second functionality, it's about the scanning an application on with using ZAP, which is installed on your phone. So the first step, as we talked about, is like you have to identify an application URL. So here on iTunes, there is an application called Hey Zap. So this is basically an application which is used to discover the new games and connect it to the friends, see what your friends are playing, and then you can start playing that game. So this particular application helps you to get that data. So you have to identify this URL. You have to copy this URL and put it into the scan interface in ZAP. So here you can see that we have given a link to install an SSL certificate. So the two ways we just talked about are being described here. So you can choose any of the method to install a SSL certificate. So after that, there is an again link which will ask you for the canary data which you want to look while analyzing the traffic of that application, like first name, last name. So this has to be a fake information. Again, this is an optional functionality which is there. So after that, you have to start a proxy scan for it. So you can see that Haze app is already being analyzed, and it has a risk score of 44. So it is asking you to reanalyze, or you just want to see the last view report. So if you go to the last view report, it will show you the same analysis what we just saw for Temple Run application. So if you start proxy rescan, it will take you to the next page where the proxy details are being shown up on the screen. So here the IP address is shown and the port which is assigned to you for that particular instance is assigned. So you have to set that port into the iOS as shown on that particular slide. You can manually enter the IP address and the port of that application and point your device to ZAP proxy for. So you can go to settings manually, you can check it, which Wi-Fi connection you are on. So I'm just checking it out on my device. So we can get the capture data for that Haze app application. So it's connected now. Just give me a second, I'll just check it. Okay. Yeah, so it's ready. And so as I mentioned, for this whole process, we have a 2 minutes timeout. So you can see that timer at the end, which is started. So when you start a proxy scan, then you have to launch that particular application and start capturing the traffic for it. So you can see that number of bytes being captured here. So it automatically starts capturing the bytes which are originated from this particular application. So you can, for this operation also, there is a 2 minute timeout. Try to hit all the functionality of an application, see what all data is originating from that application. So it will give you the proper results. So the report will have covered all the functionalities. So I have captured some of the information. right here, I'm trying to capture some more so we can have good result. So you can see that the number of bytes has been increased now. So let's try to analyze the traffic what we have captured. So you have to hit the stop capture button. Again, you can download the captured file here from this link and can be used for your analysis purpose. So if you analyze this application, you can see that the risk score for the current traffic which is captured from this particular application comes out to be 44, and which is like medium level of risk which we have seen here. So if you can see, we have tried to uh, have some checks which are running for each bucket we just talked about. So in the authentication right now, so for this uh, presentation, because of some time limits, we couldn't enter that canary data, but we are leveraging that canary data for this authentication bucket to see if the username and the passwords are going in clear text or with weak encoding format. So for the exposed contents, as you can see that we have seen that this application is contacting to some third-party site. And again, it's using some SSL for some of the traffic. So we have lowered down the risk score for that particular bucket. So the second device metadata, you can see that this application leaks UDID, device type, and the OS version. So we have seen that these are the major metadata information being leaked by iOS application and even with Android. So again, that PI information which is being entered on the first page will be used for this bucket analysis. So if PI's information is entered, then the code path of the ZAP is completely will be covered, and the results will be best result for that. So at the end, we are showing the traffic capture which is being captured for that instance. So you can see that the first request, which is dataflurry.com, is a third-party site which is there, and your application is sending data to this third-party site, like your phone UDID, like unique identifier of your phone. So you can see that your iPod type is also have been seen in there. So it's like iPod 4, which I'm using right now. So you can go through then capture data and try to analyze and guess what that application is trying to do. So the overall idea was like capture the content of a mobile application and come up with an analysis and try to rate that application. Oh, sorry, it's starting again. Let me take you to that slide.
So what do you guys think of that? You think that's easy to use, useful? Yeah? So I tell you, Pradeep and his team worked super hard over the past 3 months to get this ready for you guys today. So let's give them a hand for all the hard work that he did.
So this was all about the demo of the ZAP, and I encourage you guys to use it and give us the feedback. We have mentioned our email links over ZAP portal, and so it will be great to see you guys feedback for that to have more functionality, and for it will be great for analysis of mobile applications. Thank you.
Great, thanks. So yeah, so ZAP, we just took the password off literally minutes ago, so zap.zscaler.com is where you can access this. And so what I want to do now is walk into some of the findings. So we've just started with ZAP. We've analyzed, I think, about 500 iOS apps. We're just getting going on Android. We've only done about 50 so far. But we want you guys to help us with this. So the idea is, you know, it's really tough to analyze 500,000 apps in the App Store. So we hope that everyone will find ZAP to be a really useful tool. You guys can now analyze apps to figure out what you find, and then this will become a searchable database that anybody in the public can use. So before they install an app on their phone, they can go check ZAP and say, hey, what are the security privacy risks associated with this? And then make their own informed decision if they want to install it. So let me just talk about, what we discovered when we were doing this stuff. So we embarked on this project with the idea of looking at security issues and privacy issues. And what we found is that the impact and the prevalence of these issues were kind of the inverse. So when you think of security issues, in my graph here, I'm looking at the surface area, just kind of showing how big it is, right? So when it comes to impact, a malicious app is going to have a bigger impact than a vulnerable app. Vulnerable app is bad, but you only are impacted if somebody actually chooses to attack it. Whereas a malicious app, it attacks you at any given time. Now, when it comes to the prevalence of that, it really is the inverse. We found that we don't find too many malicious apps. Now, the malicious apps certainly grab the headlines. Like that's when you see something on Slashdot, for example, that, oh, hey, a malicious app got into the iOS store or the Android store. And that definitely happens. I'm not trying to downplay it. But the number of times that happens versus the 500,000 apps that are in there is relatively small. Vulnerable apps are more common. However, the big issue, in my opinion, isn't so much security, it's privacy. And this is different than the PC world. Privacy is a real problem. You'll see from our findings, it is extremely common. Well, it's very rare to find a malicious app, fairly rare to find a vulnerable app, very common to find an app that is abusing your privacy in some way. And sometimes that's being done on purpose. The developers said, hey, we want to grab your MAC address because that helps us track you. And very often it's just done because it was poor coding, sending your password in clear text. I'm sure they didn't want to do that, but they're rushing into this field of mobile app development and just don't have the appropriate skill sets. There isn't appropriate QA in place, and they made a mistake. So when it comes to privacy issues, again, looking at it the same way, weak authentication would have the biggest impact. If you were sending your password in clear text, that would be the biggest problem, followed by personally identifiable information leakage, device leakage, and then just communicating with a third party. And that's very common. Keep in mind, most of the apps we're analyzing at this point are free apps, so you expect them to be communicating with advertisers and analytics sites. Yet the prevalence of this tends to be the opposite. Very common to communicate with third party, but leaked passwords, although they're at the top of this pyramid, they're certainly not rare. You'll see in our stats, about 10% of the time we find leaked usernames and passwords. Think of that, 1 in 10 apps. How many apps do you have on your phone? I probably have definitely more than 100, and probably 10 of those are leaking my username and password. That's a real concern. So here's some of the findings. We often found that there was an attempt to obfuscate sensitive data, but it was a weak attempt. The developer didn't understand the full implications. So here's an example of that. Here's an application for uploading photos to Twitter. And you can see this is an HTTP packet that, the red text there shows you that. But the password, it is obviously encoded in some fashion, but all that is just an MD5 hash of the password. So, very often you'll see that. And yeah, one-way hash, but hey, that's easily brute forceable. So that's a common sort of thing. Another big problem, and I was surprised how often we saw this, was applications sharing MAC addresses. And you'll note, if you look at the green text, this isn't being sent to the developer. This is actually being sent to an advertising site that they use. And I'll tell you why this is happening. So we'll also show you how unique identifiers. Every phone has a UDID, unique device ID. And people are complaining about that for privacy reasons, because it's a problem if somebody's sending your UDID. If they have that, they don't know who you are, but they can track your behavior. One site gets a request, and it has the same UDID as another site that gets your request. Then they know it's the same person, and they can start to create a profile. So advertising sites want that information. Now in iOS 6, you'll notice there's a function kind of buried in the About screen called restrict advertising or something. And what it's doing is preventing your UDID from being sent. So Apple is locking down on this. But the developers, they're getting smart. They're saying, hey, there's other unique identifiers, your MAC address. So they're grabbing that. So I'm sure Microsoft or Apple will have to react to that as well. But people get concerned about cookies tracking them. A UDID or a MAC address is a bigger problem because you can't flush that, right? It's not like you can change your MAC address. Certainly not easily. Clear text usernames, obviously not as bad as a clear text password, but it's still something that you would rather have sent over SSL. Because if I have your username and I want to break into your account, now instead of 2 variables I need to tackle, I only have 1. Here's the eBay application, so obviously a fairly popular application. And clearly, they wanted to obfuscate it, because if you look at that packet on the bottom, you see that is an HTTPS packet. So there they intentionally tried to make sure that the username was obfuscated. But then if you look at the top packet, you'll see they obviously didn't do the same type of coding for all of the traffic. They might have been using a different library. So what's the point in encrypting something one time if you don't encrypt it another time? Leaked device IDs, this is interesting to me. It ties to the MAC addresses. As mentioned, all devices, tablets, smartphones have a UDID, just unique device identifier. And this became an issue recently in the news. I don't know if you remember, but some of the attackers from the anti-sec group claimed that they had hacked an FBI computer and got 10 million UDIDs, which caused waves because it suggested the FBI was trying to track people via their cell phone usage, which, yes, I'm sure they're doing. But obviously, they said that they weren't doing this. The FBI came out right away and said, hey, they did not get those 10 million IDs from us. We don't know where they got them from. And the FBI was not lying. Turned out that it was actually a third-party software site. Good for the CEO. He fessed up, came out and said, yeah, I know where they got those from. We just checked their database. Same million UDIDs that we have. And you might say, well, why would a software developer have 3 or 10 million UDIDs? Well, it's because of what we saw in that earlier packet. The advertisers push these libraries out to the software developers to use, and those libraries automatically collect MAC addresses, UDIDs, so that they can track the behavior, because that advertising API is now on multiple applications. So even though they don't know it's you, now they can track your behavior and send you custom ads and things like that. So they're not breaking into your device, but it's a privacy concern. I have not given permission for this site to track my behavior, and yet they're doing that. So we see UDIDs collected all the time. Here's an example of the Hangman application. You can see both UDIDs and MAC addresses, actually in this case, being grabbed and shared with third-party advertising sites. So Apple is cracking down on the UDIDs, so I expect that that will increase the use of MAC addresses. Here's a device that I actually got for Christmas this year that I really love. It's called a Griffin Beacon. Acts as that little hockey puck is sort of a middleman between your television set and your iPhone. Speaks Bluetooth to your iPhone, infrared to your TV. So now your iPhone becomes a remote control. Great device. But when I got it, I started kind of picking through it and trying to figure out what it was doing. And I noticed it was sending these requests. And you can see for my user account, it was this user ID, just an integer value. And I thought to myself, gee, I hope they're not just incrementing that digit every time they get a new user. Yep, sure enough. So if you look at number 1, that was my request. So I thought, well, I'm 46947. I wonder who 46948 is, 949, etc. So yes, you could see if you requested somebody else's account, it would send you back their viewing history. And so you can see this is Julia Ballard. But what was more interesting to me is you can see that it includes Facebook information because it asks you for that. So now I could then go to that person's Facebook account, and I'm actually tying a person, not a number, to actual knowledge of them. In this case, their TV viewing habits. So I wrote a script, collected all the data from 50,000 users. Now I get to know what they all watch on TV. Weak authentication. This is the most frightening, and literally 10% of the time we see it. Password sent completely in clear text. If you look at the blue, you can see Zscaler with the 3. That was the password that we were using. Frighteningly common. And even more concerning is that we see that same behavior. You can see password being sent in clear text. But what we also found is when we would identify a problem in one application, we would then go look at all other applications by that same developer. Very often it was in all applications because they would write one library to do the authentication functionality and reuse it. So here's a case where there were 4 apps, all have the exact same problem. When we looked at it, we figured out, yeah, they were all by JDI backup. So as I mentioned, malicious apps tend to be a component of Android. Like if you look at the very top of that list, this data is from, I believe, F-Secure. Over the past year, they found 129 malicious apps in Android, only 2 in the iOS App Store. So the malicious apps is a bigger problem, but privacy we find is pretty equal across the board. Here, we'll focus on iOS stats for this last piece of findings because that's where we've done the most work and we're most comfortable with our stats. But it's the only good bar in here is that green one on the left. We see that nearly 80% of apps are using SSL, at least in some part of their communication. That's great to see. But 60% leaking device information, things like UDIDs or information about your OS. About 35 to 40% are talking with third parties. That's somewhat to be expected since these are free apps. But most concerning is the authentication leaks. 10 to 12% they're leaking either your password or your username. Frighteningly common when you consider the number of apps on your devices. Breaking down some of those items, what I did is you'll notice I highlighted 3 bars for all of these. I highlighted games, social networking, and business, just because I feel that the games, the social networking, that tends to be geared more toward the consumer audience, business obviously toward enterprise. And I wanted to see if enterprise apps were more secure. In this case, it would suggest that they are. Business apps are more likely to be using SSL, but it wasn't always the case. Communicating with third parties, business apps were a bit more secure, less likely to be communicating with a third party. Business is always the blue line. Communicating with advertising, very, very common across the board, although again, less common for business. Leaking passwords, frighteningly common across the board. Look at some of those top news and productivity. It was extremely common. Usernames, same idea. And then personally identifiable information. So again, this is anything about you that's not your username and password, your email address, your phone number, your physical address, also very common. And the UDID is the most common, but we expect that this to be, Apple is locking down on this, but expect to just see the developers switch to other unique identifiers like the MAC address. Apple definitely needs to lock down on that as well. So just in conclusion, so we feel that even though the media tends to focus on the security risk, that's what's making the headlines like, hey, here's a malicious app, a vulnerable app that we found in the App Store, the prevalence of privacy issues is far, far greater, and that's really where we as a security community should be focusing our concerns. We found just frightening low-hanging fruit, like 10% of apps sending your password in clear text. There is no excuse for that kind of stuff. And when we look at Android versus iOS, privacy risks were pretty equal, at least at this point of our analysis across the board. It's not that Apple or Android is better or worse. They both have problems. Malicious apps, though, that tends to be more a product of the Android store. And even though Google has implemented Bouncer as a means to automatically scan apps, and that has helped somewhat, there are ways to get around Bouncer, and now researchers are publishing information to help you get around Bouncer. So what is the cause of this? Well, it's what I said at the very beginning. There's this explosion in apps, and there just aren't the right skills in terms of researchers, security tools. Developers don't have good security knowledge in this area, so we have a lot of work ahead of us as an industry. What's the solution to all of this? Well, we can obviously help by calling out bad developers, and hopefully Zap will help with that. I think the ultimate solution is that the App Store gatekeepers play a bigger role. They are a single point of contact that blesses these apps, and they are clearly not doing any security research, because if I can find that an app leaked the password literally in 30 seconds, that's how long it takes you using Zap, they can definitely do it before they put it in their App Store. So with that, I want to thank you for coming today. Remember, zap.zscaler.com is where you can start playing with this. Threatlabs.com, we call the research arm of Zscaler Threat Labs with a Z, so there's a lot of cool stuff, a lot of other projects, free tools. And last but not least, we are hiring, and we are hiring here in India, and we want to grow the team. If you thought this research was cool, and you're a researcher that plays in this area, or you're a developer that loves security and has good web security knowledge, drop a resume to Threatlabs at zscaler.com, because I really want to talk to you. We have offices here in Bangalore and Chandigarh. So thank you for your time. Certainly open to any questions you might have about Zap or anything that we talked about. Yeah. Out of time? All right. Talk to me after the presentation.
Oh, thank you. Thank you.